Welcome back students to the part 2 of today's session. In this module, let us discuss about the center of gravity and moment of inertia. Center of gravity is an imaginary balancing point where the body weight can be assumed to be concentrated and equally distributed. Its symbol is Cg. It is a point of exact center around which the body may rotate freely in all directions. It can also be called the center of mass. To find the center of gravity of a planar object, let us put 3 holes in that irregularly shaped planar object and hang any weight from one of the holes. So, the laminar object will rest in some particular direction. So, draw the vertical line through the hole where the weight is balanced. Now, let us hang the same weight through the different holes and mark the vertical line of the thread. Then we can see that these points coincide at a particular point, and that point will act as the center of gravity. You might have seen Hit Me dolls. In those dolls, particular weights will be distributed and the entire weight will be concentrated at one point, which is at the bottom center point of the toy. So even if you try to shake it or move it in any direction, it will come to rest at the center of gravity. Another application is to design the ground support structure for the goal post. It is critical to find the total weight of the structure and the center of gravity location. An integration must be used to determine the total weight of the goal post due to the curvature of the supporting member. Now let us discuss about the topic moment of inertia. You are familiar with the term inertia for linear motion. In the case of rotational motion, it is known as moment of inertia. The more the inertia, we know it is harder to change its linear motion. Likewise, rotating bodies possess a rotational inertia which is called the moment of inertia, and more the moment of inertia, the harder it is to change its rotation. For a single point mass like m with respect to a particular point which is at a distance of r from the axis of rotation, moment of inertia I is defined as mr square, where m is the mass of the object and r is its distance from the axis of rotation. If there are many particles or a system of particles in the object, then total moment of inertia I can be written as sum of mi/ri square, where I is changed from 1 to n, where 1 to n represents the number of particles. Now let us find the moment of inertia of this simple planar object. Let m1, m2 and m3 be the 3 point masses which are at distances r1, r2 and r3 from the axis of rotation. Then the moment of inertia of the body I is given by m1 r1 square plus m2 r2 square plus m3 r3 square plus etc., which can be written as summation from I equivalent to 1 to n mi/ri square. The moment of inertia measures the resistance to change in rotation, and moment of inertia I is equivalent to mr square for a single mass. Total moment of inertia is due to the sum of the masses at a distance from the axis of rotation, that is I is equivalent to summation from I equivalent to 1 to n mi square. Now let us define about the radius of gyration. The radius of gyration of a body about an axis is defined as distance from the axis of a mass point whose mass is equal to the mass of the whole body and whose moment of inertia is equivalent to the moment of inertia of the body about the axis. Moment of inertia is represented by I. Radius of gyration is represented by K. In short, we can write mk square is equivalent to I, which is equivalent to summation mi ri square. SI unit is meter and dimension is L for radius of gyration. The flywheel, which is an essential part in all the automobiles, also works on the principle of moment of inertia. Now, the moment of inertia of certain objects about some particular axis of rotation are given to you. For example, in the case of a solid cylinder, about an axis passing through its center or axis, the moment of inertia I is given by half mr square. Similarly, for a solid sphere, along any axis through its center, moment of inertia I is equivalent to 2 by 5 mr square. Similarly, for a solid cylinder about an axis which is along the diameter of its cross-sectional circle is given by I is equivalent to 1 by 4 mr square plus 1 by 12 ml square. Hope you have got an idea about center of gravity and moment of inertia. Thank you, dears.